Hello, I'm Mrs. J, and today we're going to talk about section 4.6, which is logarithms and numbers. And when you're working with a log, it has a base. So log base b of x equals y, it can be rewritten as b to the y equals x. Now, one way of remembering, start with your base and loop around. So b to the y equals x. B to the y equals x. Same thing here when you're going around. Start with the base. Log base b of x equals y. Log base b of x equals y. Just loop around. When there is no base, if they don't have it there, it's base 10. So if there's no base, it's automatically base 10, and base 10 is what your calculator uses. So if you have a different base, then you need to rewrite it with a change of base. So if we look at these, we want to rewrite them as logarithms. Start with the base and loop around. So log base 10 of 10,000 equals 4. Here, starting with the base and looping around. Log base 10 of 123 equals x. Likewise, we can go the other way and rewrite them. Remember, when there's no base, it's a 10. So 10 to the negative 6 equals 1, 2, 3, 4, 5, 6. So no base, put a 10, and then loop around. 10 to the 7 equals x. A little easier than remembering a formula, just remember a loop, and always start with the base. When the base and this number are the same, it just equals the exponent. So log base 10 of 10 to the r is just r. So we can solve the following without a calculator then, because we know when there's no base it's 10, and we can rewrite this as log base 10 of 10, 100 is 10 squared. Rewrite it in scientific notation, it'd be 10 squared. So it equals 2. Log base 10 of 10 to the 1, 2, 3, 4, 5, 6, 7. So 10 million is 10 to the 7th, because there's 7 zeros. It means it's 7. You're just writing the scientific notation. So this is log base 10. And we can write this as 10 to the 1, 2, 3, negative 3. So it's negative 3. Last one. Log base 10 of 10 to the, because we'd need to move here for scientific notation, 1, 2, 3, 4, 5, 6. So our answer would be negative 6. For y equals log of x, x has to be greater than 0. You can never take the log of a negative value. Okay. X has to be greater than 0. If you plugged in your calculator log of 0, you're going to get an error. The same thing if you plug in a negative value. So it has to be greater than 0. So when you're solving these, you should check your answers. So if we solve for x using a calculator, We first want to rewrite it because we can't put log of x in our calculator. But we know there's no base, so it's 10. This can be rewritten, then use your loop. 10 to the 8200ths equals x. And then we can plug that in our calculator. And depending on your calculator, different ways of plugging it in, but mine is 10 and I use the caret, and it was 0.82. We get 6.6. I'm going to just round to the 10th. Try another one. Put a 10 here. 10 to the 13th equals x. Now this one I don't need to plug in my calculator. I know that means 13 zeros. Thousand, million, billion, 10 trillion. 1, 2, that's not 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. Oh, that makes sense because terabytes is 12. These ones, we need to go the other way. Because the x is in the exponent, we need to rewrite it. Log base 10. Start with your base and loop around. Log base 10 of 0.012 equals x. Just flip around. My calculator's base 10, so I push the log button. And then I put in my number, which was 0.012. And I get a negative 1.9. So it's approximately a negative 1.9. This one, again, rewriting it. Log, writing a 10. Log base 10 of 136 equals x. Plugging that in. Log, remember the calculator's automatically base 10, 136, 2.1. Solve without a calculator. Okay, so we could rewrite this because it's base 10. Log base 10 of 100 equals x minus 2. Well, we know 100 is 10 squared. When these two are the same, it equals the exponent. So it's 2 equals x minus 2, and then just add the 2 to the other side. We get x equals 4. Okay. Over here, again, we can rewrite it. Log base 10 of 0.1230001 equals 10. Whoops, got rid of the 10 because we're rewriting it. Start with the 10 and loop around. 3x minus 1. So log base 10 of this number equals the exponent. This is log 10, 1, 2, 3, 4, 10 to the negative 4. Negative because the 10 needs to get smaller. Equals 3x minus 1, which means negative 4, because these are the same base, equals 3x minus 1. add the 1, and we get -3 equals 3x. Let's move this over here. And divide by 3. X equals a -1. Okay, again, we want to solve without a calculator. There's no base, so we know that it's 10. And then we can rewrite it. 10 to the first equals x minus 4. 10 to the first is 10. And we can add the 4 to the other side. And we get 14 equals x. Try one more. Log 500 minus 2x equals 3. Okay, no base, we know it's 10. Rewrite it. 10 to the third equals 500 minus 2x. Well, 10 to the third would be 3 zeros. And then we're trying to get x by itself, so we'll subtract the 500. And divide by the -2. So x is a -250. Let's look at another one. The difference in noise levels of two sounds is measured in decibels, where decibels equals 10 log of I sub 2 over I sub 1. And I sub 1 and I sub 2 are intensities of the two sounds. Compare noise levels when intensity 1 is 10 to the -15 watts per centimeter squared, and I2 is 10 to the -8 watts per centimeters cubed. So to compare the decibels, we plug it in here. 10 log I sub 2, so 10 to the -8 over 10 to the -15. Now we know when we divide, we subtract the exponents. So this will be 10 log 10 to the -8 minus a -15. 10 log 10 to the +7. Well, we know that the log is base 10 when there's no base. So these are the same, which leaves us 7. So we have 10 times the 7, or 70. So the one noise is 70 decibels louder than the other. And so you can just simplify your logs. There's one more I wanted to show you on page 254, number 20. See if we can make it a little clearer. There we go. Place the 50 on the number line of the additive scale. Notice that because it's additive, it's counting equal spaces. So if this is 100, looks like it's tens then. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So it's going by tens. So 50 would be 10, 20, 30, 40, 50 right here. Right in the middle. This one is going by base tens. So to find where it would be, we'd need to take the log of 50. Log 50. that sun is shining, 1.7. So it would be 10 to the 1.7, it'd be right here. So this would be going by a multiplicative scale of base 10. And this one is going by units of 10, 10, 20, 30. Okay, and that's everything from this section.